Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Velocity is a Java-based template engine designed to generate dynamic content such as HTML, XML, or even source code. It uses a simple scripting language called VTL or Velocity Template Language, which allows developers to separate business logic from presentation. This makes it ideal for web applications, email templates, and even code generation tasks. Velocity is part of the Apache Software Foundation, ensuring it's open source and community maintained. Velocity stands out because of its lightweight nature and efficient runtime performance. It enforces a clean separation of concerns, which is essential in large-scale applications. With support for reusable macros, template caching, and seamless integration with Java frameworks like Spring and Struts, Velocity is a reliable choice for enterprise-level templating needs. At the heart of Velocity is its template language, VTL. It's designed to be simple and non-procedural, making it accessible to both developers and designers. Common directives include #set for variables, #if for conditionals, and #for each for loops. You can also define reusable macros, include other templates, and manage complex layouts with ease. The Velocity engine is the central API used to configure and process templates. It supports various resource loaders, such as file system or classpath-based ones. The engine also handles template caching, which boosts performance in repeated evaluations. You can configure it using properties or programmatically, and it's designed to be thread-safe for use in high-throughput applications. The Velocity context is a key value store that holds the dynamic data you want to inject into your templates. It supports nested objects, lists, and maps, making it flexible for complex data models. It's crucial during the template merging phase and should be instantiated per request to maintain thread safety. Velocity supports a variety of resource loaders to fetch templates from different sources, including the file system, classpath, JAR files, or even databases. Its pluggable architecture allows for custom loaders, and templates are cached for optimal performance. You can configure these loaders via VelocityEngine properties to suit your deployment needs. One of Velocity's strengths is its built-in template caching. Once a template is parsed, it's stored in memory, which drastically reduces overhead and repeated evaluations. This is especially useful in high-throughput applications like web servers or batch processors. Caching behavior is configurable, allowing fine-tuned performance control. Macros in Velocity allow you to define reusable template snippets. They're declared using the #macro directive and can accept parameters, making them flexible for various use cases. Macros help reduce redundancy, improve maintainability, and are perfect for component-based templating strategies. Velocity provides robust error handling and logging capabilities. You can configure how errors are reported, integrate custom logging frameworks, and ensure graceful degradation in case of template issues. This makes it easier to debug and monitor applications in production environments. Velocity supports optional sandboxing, which restricts unsafe operations in templates. This is particularly useful when dealing with user-generated content. You can configure method and property access restrictions to prevent malicious behavior, ensuring secure template rendering. Here's how Velocity's architecture works in a nutshell. The Velocity engine processes templates using data from the Velocity context. Resource loaders fetch the templates, which are then parsed and optionally cached. Finally, the merged output is generated and returned to the caller. Let's walk through a typical Velocity workflow. First, initialize the Velocity engine. Then, load a template using a resource loader. Next, populate the Velocity context with your data. Merge the template with the context, and finally, return the rendered output, whether it's HTML, XML, or another format. In web applications, Velocity is often used to render views in frameworks like Spring or Struts. Templates separate HTML from Java logic, making it easier to manage dynamic content like user profiles or dashboards. This approach enhances maintainability and scalability in large applications. Velocity is also widely used for generating dynamic email templates. You can personalize emails with user-specific data, reuse templates across campaigns, and support both HTML and plain text formats. This greatly reduces boilerplate and streamlines email workflows. Velocity is a popular choice for code generation tasks such as ORM mappings or scaffolding. By using templates, you can generate repetitive code with high consistency and fewer errors. It's commonly used in IDEs, build tools, and enterprise development pipelines to automate boilerplate generation. Velocity is known for its lightweight design and efficient performance. Template caching and optimized parsing contribute to low overhead and high throughput. It scales well under concurrent loads and offers performance on par with other popular templating engines. When compared to alternatives like ThymeLeaf, FreeMarker, or JSP, Velocity offers a simpler syntax and better separation of concerns. While it may be less feature-rich than FreeMarker, it's more powerful than Mustache and ideal for Java-centric templating scenarios. Integrating Velocity with Spring is straightforward using Velocity View Resolver. You can define custom directives, configure it via XML or Java config, and leverage it in MVC-based applications. This enhances modularity and makes your views easier to test and maintain. To get the most out of Velocity, follow these best practices. Use macros to reduce redundancy, keep templates logic-free, leverage caching for performance, validate context data before merging, and use sandboxing when handling untrusted templates. Despite its strengths, Velocity has some common pitfalls. Runtime errors can occur due to type mismatches, performance can suffer without caching, and overuse of logic in templates can reduce maintainability. Be sure to manage context properly and implement error logging in production. Setting up Velocity in a Java project is simple. Add the Velocity dependency, initialize the Velocity engine, configure resource loaders and properties, create a Velocity context, and merge your template with the context to render the final output. Let's walk through a sample Velocity template. You can use #set to define variables, #if for conditionals, #for each for loops, #parse to include other templates, and #macro to define reusable snippets. This gives you full control over dynamic content generation. Debugging Velocity templates involves enabling detailed logging, using built-in error messages, validating context data, testing templates in isolation, and leveraging IDE plugins for syntax highlighting. These practices help identify and resolve issues quickly. Velocity is highly extensible. You can create custom directives, implement custom resource loaders, add error handlers, extend the engine with plugins, and integrate with logging or monitoring tools. This makes it adaptable to any enterprise workflow. In enterprise systems, Velocity is used for report generation, configuration templating, multi-tenant email workflows, legacy system integrations, and high-volume batch processing. Its reliability and performance make it a go-to choice for large-scale operations. While powerful, Velocity has its limitations. It lacks built-in template inheritance, has no compile time type safety, and debugging can be tricky. Its community is less active compared to modern tools, and it's not ideal for logic-heavy templates. Velocity is a mature and stable technology, but it's not actively evolving. It's still widely used in legacy systems, and community support remains consistent. While newer templating engines may replace it in new projects, Velocity remains a solid choice for maintaining existing codebases. To dive deeper into Velocity, check out the official Apache documentation, Spring integration guides, YouTube tutorials, GitHub sample projects, and community forums like Stack Overflow. These resources will help you master Velocity in no time. In summary, Apache Velocity is a powerful and flexible template engine for Java. It uses VTL to cleanly separate logic from presentation, supports caching and macros, and integrates seamlessly with major frameworks. Whether you're building web apps, emails, or code, Velocity is a reliable tool to have in your toolkit. Apache Velocity remains a great choice for legacy and enterprise systems. Its simple syntax makes it easy to learn, its performance is solid, and it's ideal for Java developers and architects. Despite newer alternatives, Velocity is still very much relevant in today's development landscape. If you found this tutorial helpful, don't forget to hit like and subscribe for more content on Java, templating engines, and enterprise development. Drop a comment below with your use cases or questions, and check the description for useful resources. See you in the next video. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.